Welcome, algebra students. Today we are starting chapter 6, which is polynomials and polynomial functions. We're going to start with section 1, day 1, which is operations with polynomials. Today we're going to focus on exponent rules. Tomorrow we're going to actually do the operations with polynomials. Look at today. Today we're going to simplify exponential expressions, including negative exponents. For the ACT, you have to be able to apply the rules of exponents. This is something that you learned freshman year in Algebra 1 or in 8th grade whenever you took it, and then we're going to learn it again. Okay, first thing, if you could please draw yourself this table. If I move too fast to give you enough time, you might want to pause the video. Okay, so the first rule we're going to look at is the product of powers rule. So an example of this is x squared multiplied by x to the third. Remember that x squared is x and x. X to the third is 1, 2, 3. So in total, this is 5 x's. So in general, if we have x to the a multiplied by x to the b, you want to add the exponents, not multiply them. Quotient of powers, that's like x third over x squared. So this is x over 2 x's. You're left with just 1x. So in this case, you don't want to divide those exponents, you want to subtract them. So if we have x to the a over x to the b, this becomes x to the a subtract b. Negative exponent. If we have x to the negative second power, we want to flip, take the reciprocal. So this is like over 1. So move that x to the negative second down to the denominator. Becomes 1 over x to the second. In the process, the negative exponent becomes positive. We don't like negative exponents, always want to make them positive. So if you have x to the negative a, that becomes 1 over x to the a. Power of a power. Example of this is x to the third squared. Remember that x to the third is x multiplied by x multiplied by x. When you square something, that's just multiplying it by itself. So that means we have 3 more x's. So in this case, this becomes x to the 6th. So we multiplied them. So if we have x to the a to the b power, this case, you can multiply those exponents. That's different from the first rule we learned when we just added. Okay, power of a product. That's like xy to the a power. That a can be distributed. So we have x to the a and then y to the a. So an example is if we have x, y squared to the third power, distribute that 3. This becomes x to the third, y to the 6th. Going off of that previous rule, this one right here, where we want to multiply. Okay, I know I'm going kind of fast, but we did learn these before. 2 more. Power of a quotient. Remember that quotient means divide. This one's really similar. So if we have x over y to the a power, just distribute that a. X to the a over y to the a. So if we have x over y squared to the third power, this becomes x to the third power over y to the 6th power. It's like this x has a exponent of 1 if we don't write anything. Last one, 0 exponent. Anything to the 0 power is always 1. So 5 to the 0 power, always 1. Okay, so we have 2 examples to do together. You have 2 to do on your own, and then we are finished for the day. Okay, moving on to our first example. I'm going to suggest that right now you pause the video so that you can write down those steps to the right. Okay, hopefully you paused the video and had a chance to write down the steps. So for this first example, it says step number 1 is to distribute any powers. What that means is distribute any powers that are outside of the parentheses. In this case, we don't have any of those. So we're going to move on to step 2. Change negative exponents to positive by moving. Okay, so we have a negative here, a negative here. Remember that in order to change a negative exponent to a positive, we need to move from numerator to denominator. So this 2y to the third can stay in the numerator. Remember that this is all over 1. That x to the negative third has to move to the denominator. In the process, it becomes positive. The second one, remember this is all over 1. That negative 7 has an exponent of 1, so don't move that. X to the fifth can stay where it is. Y to the sixth moves to the denominator in order to become positive. Okay, now combined horizontally, so that means go like this. 2 multiplied by negative 7 is negative 14. X and y we can't combine, so that's y to the third, x to the fifth. X and y again we cannot combine, so x to the third, y to the sixth. Last step is to combine vertically. That negative 14 has nothing we can combine it with, so it stays. Remember that we want to subtract exponents when we have a quotient. So 3 subtract 6 is negative 3. 5 subtract 3 is 2. Remember how I said before, we're not allowed to leave those negative exponents. So our last step is to make that negative exponent a positive one. So remember this is all over 1. Move from numerator to denominator. So our final answer becomes negative 14 x squared all over y to the third. Okay, here's our second example. So our step number 1, we said, is to distribute any powers. So that's what I'm going to start with, distributing this 3. So this becomes negative 2 to the third power, a to the negative 12th, because of the power to a power, a to the third, because remember that this is the first power, and then b to the 6th, because we want to multiply. Before we go on to step number 2, I just want to simplify this part. Negative 2 to the third power, that's negative 2 multiplied by negative 2 multiplied by negative 2, which becomes negative 8. And then a to the negative 12th, all over a to the third, b to the 6th. Okay, step number 2 was to get rid of any of those negative exponents. So we're going to move from numerator to denominator. Remember that this negative 8 has an exponent of 1. It's a positive exponent, even though it's a negative number. So negative 8 is the only term that we keep in the numerator. Denominator, we have a to the 12th, a to the third, b to the 6th. Okay, now what we want to do is combine horizontally. Negative 8 has nothing we can combine it with. This a to the 12th and a to the third, we can add those exponents. It becomes a to the 15th, and then b to the 6th. We don't have anything else we can combine, so that is our final answer. Here are our last 2 examples that you're going to try on your own. Pause the video, try both of them, and then come back when you're finished. If you run into any problems, you can always go back in the video. Okay, hopefully you had a chance to try these. First thing I'm going to do is get rid of the negative exponents. If you did not put that over 1, that's fine. Okay, now I'm going to combine everything horizontally. 2 multiplied by 3 is 6, and then we have a to the third, b squared, all over a squared, c squared. Last thing that we can do is combine those a's. So this becomes 6ab squared all over c squared. That's the final answer. Second example, first thing I want to do is distribute that 2. So this becomes negative 15, c to the negative 5th, d to the third, all over 9, c to the 8th, d squared. I want to get rid of this negative exponent by moving it to the denominator. That becomes c to the 13th when I combine those c's. Okay, now I have d in the numerator, d in the denominator, so I'm going to subtract the exponents. This becomes negative 15d, because 3 subtract 2 is 1, over 9c to the 13th. You are not finished yet. Last thing that you have to do before being finished is simplify this negative 15 over 9. That's just a fraction, negative 15 over 9. So what's the greatest common factor of negative 15 and 9 is 3, so divide both by 3. We get negative 5d all over 3c to the 13th. This is your final answer. Okay, look back at what we did today. Today we simplified exponential expressions, including those with negative exponents. I just would like to apologize for the visuals of this video. I know they were a little trippy with the double text. But thank you very much for listening and taking notes, and have a nice day.